Okay, so in the past video we covered saturated fatty acids, and I'd like to briefly talk about unsaturated fatty acids. What's the difference? Now the difference is in the fatty part of the molecule. So this part right over here. What changes between saturated and unsaturated? It's a difference in the bonds between carbon and carbon. As you can see right over here, there is a double bond between these two carbons. In the saturated fatty acids, there were only single bonds. So what's gonna change? There are different things that change. For example, the chemical properties of this molecule, which is going to have a freezing point which will be lower than the saturated fatty acids, and it's going to have right over here just one hydrogen bond to this carbon and one to this carbon right over here. Oh, by the way, why did I put them right over one on the bottom and one on the top? Because this is a trans configuration. If it were a cis configuration, just like this over here, you would have two hydrogens all on the same side. Now this configuration, it's cis and trans. It's a thing which happens with double bonds, because a double bond is not cannot rotate. Unlike these, which can rotate, this double bond cannot rotate. So the position of these hydrogens determines the shape, as you can see, of the chain, and it determines other properties of the molecule, and it is useful for knowing the name, whether it's cis or trans. Anyways, unsaturated fatty acids can be monounsaturated, like this right over here, if there's just one in unsaturation, one double bond between two carbons. Mono means one in Greek. If there were two or more, then it would be polyunsaturated. And what happens is that you need to give a position to this unsaturation. So there are two ways of giving names, which are, first, it's called delta, in which you start counting the carbons from this from the carboxylic, the polar part group, starting like 1, 2, 3, 4. So this is going to be delta 4. And then the name of the acid, which depends on the number of carbons. In fact, the length of the chain can obviously change, and you will have different types of molecules which have different names and different properties. For example, you have C14, you're going to have one type of molecule. I don't remember, frankly, whether it's C14 or C16, the palmitic acid, which is very present in animals anyways. Now, they're going to have, by the way, a different melting point, because if you think of the molecule, these molecules right over here, the saturated fatty acids, can stick up together more closely, so that there's going to be less space and less possibility for these molecules to move easily. So they're going to have the tendency to stay still and and to melt, it's going to need a higher temperature. Saturated fatty acids are particularly present in animals. That's why, for example, butter has a lot of these fatty acids over here, and that's why butter is mainly solid at normal temperatures. it melts at high temperatures, while olive oil has more of these unsaturated fatty acids. Anyways, the cheese configuration is the one which is more present in nature. So you're going to mainly find this right over here. If you think of it, the saturated fatty acids are going to be like, well, this isn't a very good representation, but they're going to be more backed up. So if you think of millions of these molecules, one next to the other, there's going to be less possibility for them to move. If you have one of these unsaturated fatty acids, you're going to have something like this, and then it gets crooked. So then there's another one which maybe gets crooked the other way, or I don't know. It's more messy, and so it's easier for this to melt at lower temperatures. I mean, it melts at lower temperatures. Now, fatty acids become the phospholipids or triglycerides mainly, which are very important lipids in our body. How does that happen? It happens because it forms an ester bond between the carboxylic group and two hydroxylic groups from other molecules. This is a hydroxylic group. For example, let's take triglycerides. Those are they're called TAG